Okay, hi guys. Thanks for this opportunity. I'm going to just give a brief overview of the rebuilding of a Magneto. And what's important is that we're talking about a single stack Magneto for the later cars, not the earlier cars, double stack Magneto. Basically, to start off with, this is typically what you would get out of an engine that's been enclosed, an oily old Magneto ring. It might look okay to reuse, but quite often there's some hidden defects and you don't notice them initially. It's always worthwhile redoing a Magneto ring before installing it back in the car, simply because it's so deep into the engine. You don't get to it very easily other than stripping the entire engine down. If you look at this one, you'll see there's some markings over there, for example, where there's some damage. Over here, there's some damage, and it's not going to be long and it won't be working anymore. Alternatively, this is what I started off with, an old couple of old rings which are dry, and they're not oily, but they're damaged. And sometimes that's all that you've got to use to salvage, to be able to work with. And this is what I bought my initial coil from. I think that looks similar to this. The first step obviously is to remove the insulation. This it's got varnish, typically varnish over the insulation, and then there's two gaskets sitting under the insulation here. If you're careful, you can reuse those, but I'll show you that in a short while. It's basically a bakelite type of material. I'm just going to show you a short video clip of what it entails to remove the old winding or the insulation, and basically get the gaskets off as well. It's could be a bit of a messy job, quite a bit oily. Takes a bit of time. You would obviously try not to damage the ribbons themselves. And if you work, as I said, if you work carefully, you can recover the gaskets. As you can see there, they're very brittle, but they are reusable. That's what the gaskets would look like that have come out of the system, that can be reused again. This is what the ribbon would look like with the insulation and the gaskets removed. And what I do here is to slightly release the winding and then soak it in what I would refer to as one of the most expensive solvents on the market today, and that's petrol. Basically, that's what it would look like on the left-hand side once you've released it a little bit, so that the solvent or the petrol can basically get to the oil and dissolve the oil as best as possible. Once you take it out of the oil on the right-hand side, that's what it would look like, and you'll have this dry paper-like insulation material, which is originally on the ribbons sitting there. Now, the next step would obviously be to clean up that junk off the ribbon itself. What I've used is I've got a piece of square tubing which I've made long enough so that I can attach it to a frame that I've got, clamp down the ends of the ribbon on both sides. When you lay it out, it's roughly 11.5 foot or 3.5 meters. And what I've been using is to use a wire brush on an electric drill. Initially, I used a fairly heavy drill that can run in forward and reverse with a small wire brush on it. But the heat that gets generated tends to stretch the ribbon slightly, so then it becomes a little bit floppy on the working surface. So I tend to want to hold this surface with a spare hand so that it stays onto the square tubing that I've got. Later on, I started using an old, cheap little, very old 300-watt hand drill, which is lighter, that you can operate easy on one hand, but it can only run in one direction. And when the wire brush gets worn in the one direction, you would like to use it on reverse, and then you can use quite a bit more. Once it's been cleaned up, then you would wire brush, then you would clean it with some thinners in a paper towel, for example. I will just show you a short video clip on what it entails to clean it up. See, I try to get them fairly clean, remove all the oxidation. Maybe it's not necessary to go all to that extremities, but it takes quite a bit of time. Obviously, you need to clean the ribbons on both sides as well. So once you've done the one end, you move it and you turn it around and you do the other end the same, and then clean it up with some thinners once that's been done. The next step is to apply the electrical insulation to the ribbons. There's two that we can find in South Africa at the moment. The one is the Scotch 27 glass electrical tape, fiberglass type of thing. It's extremely expensive, and depending on the width of the ribbons that you would use and the width of the tape you can use, that's going to determine how much you will be able to use. In my case, I was only able to get hold of the Scotch 27 at that point at about 400 Rand a roll, and I virtually used 3 rolls on the Magneto. Kevin Casey has sourced a cheaper version, the 3D tape, which he managed to source in Harry Smith. Basically the same thing, except that it's got a removable backing tape, which just a little bit clumsy, but it's obviously for the price difference, it's a little bit wider and significantly cheaper, and you'll manage to do a complete Magneto with just one of these rolls at just under 300 Rand a roll. So there's quite a significant price difference. That is basically the two different ribbons that I managed to trace, or you find in the parts that I was working with. The one is 5mm and the one is 6mm. So in the event of using, I was able to use a 6mm and the 12.7mm wide tape. I managed to get two ribbons next to each other. Whereas if you're using the 5mm and you use a wider tape, you can probably fit 3 next to each other to link it to any be able to apply the tape and save some of the tape itself. The next step, as I said, is you lay them out on and here I work on a wooden surface. You lay them out next to each other and just keep them in place with some masking tape every couple of inches, or so that they don't fold over each other or open up too wide apart from each other. And as I said, the number of ribbons will be determined by the width of the tape as well as the width of the ribbons themselves. You must make sure that you apply the tape to the entire width of the ribbon, that it's covered, that it doesn't cause a short circuit. Once again, I'll show you a short little video on how that is basically applied. Here you can see I was working the 12mm tape, or just over 12mm, and 2 6mm ribbons. So you have to work fairly carefully to make sure that it sits quite center. There's no spare tape that overlaps on the ends. And there you can also see the masking tape that I applied to keep the ribbons in place while I apply the insulation tape itself. Go. Ribbons done. 2 ribbons done. Basically just trim the excess tape, and then you can separate the ribbons. And that I used to do with a carpet knife, and cut it in the middle, as you can see in this video clip. It's fairly straightforward. And it doesn't matter if there's a bit of tape sticking out on the sides, because that will just fold over and prevent the sharp edges of the copper ribbon from cutting the final insulation covering that you will apply later on. So there we have the ribbons taped up. There's basically 16 ribbons, so you would do at least 8, or if you get 1/4-inch tape, then you obviously have to do them 16 times. The next step is to wind the ribbons into spools with the 16, 8 of the 16 are wound in a clockwise and the other 8 in an anti-clockwise direction. And that is basically so that you can generate alternating current and not direct current, which is what you want for the Magneto. And they must also be wound in such a way that they fit tightly around the lobes of the Magneto ring, but not too tight so that you damage the insulation when you basically fit them. To get this right, it took a couple of tries. I made a mandrel the same size as the one on the Magneto ring, and I fitted that to a crude winding electrical cord winder. So it's a crude disc that I made up, but it basically worked. There you can see the size or the little lobe on the Magneto ring, and on the right hand side is my version which I made, which is the same size, and I've just mounted that on a wooden block, and I've made this backing plate which fits over the ring, and the next slide will show that clearly. And that's basically just to ease the removal of the ribbon once it's been wound. There's my winding device assembled, and there you can see the backing plate in place. What you now would do is you would bend over a tab of the ribbon and just give it a knock with a hammer, and that's what you will end up with, is that tab sticking out on that ribbon lying over there. You bend it at a 45-degree angle, which you bend it, which will give you a final 90-degree angle once you've bent it over. If you bend it at a 45-degree angle, approximately 50 millimeter, then you basically by hand attach it to the mandrel with a tape side to the inside. Give it a 1 or 2 turns so that it basically gets itself in position. And it's important to use a cloth or a glove for this purpose, that you don't cut yourself with the tape. The cuts don't heal very easily when you cut yourself with a copper insulation. Each coil has got about 21 turns. It's not going to matter if you turn short, 1 or 2 inches short. And then obviously remember to mark them clockwise or anti-clockwise. The coils that will basically be marked at the end as once you've wound them. And what I do is I wind 8 in the one direction, get that over with, and then do the 8 in the other direction. I'll just show you how the winding works. There, I'll put the backing plate onto the mandrel and the bent over tab, and with the insulating tape side onto the mandrel. Just give it a wind to get it started. 1.5 wind turns or so normally gets it into position. And it must be wound reasonably tight. Don't have to force it, but it mustn't be too loose. So then I'll just hold that in place with a rag and basically wind it 21 turns. You can see when I remove it with a backing plate, which just makes it so much easier. Then it doesn't jump out of its winding and go all over the place. So it keeps it nice and tidy. And you use a short piece of the insulating tape just to tape it up in position. And then you start with the next one basically. Make sure you use a sharp scissors. Mine's a bit on the blunt side. Or a carpet knife also cuts it nice and easily. Just tape it up anywhere in any position, just to keep it from unwinding again. As I mentioned, make sure that you keep on marking them so that you get the left or the right or the anti-clockwise or the clockwise. Here you can see the top 4 are wound in a anti-clockwise or at least a clockwise direction. It doesn't matter what you want to call it, left or right or anti-clockwise, as long as 8 are in one direction and these bottom 8 are in the opposite direction. And you, as you can see, I've marked them the R, and it's not so clearly, but they've got an L on for the left hand turning, basically. Next step is to insulate the coil by taping them up. And once again, make sure you keep record of the marking that you got the left hand and the right hand ones with. When you tape them, you basically overlap roughly about a half width of the tape. Short little video is going to show you that, and I've had to speed this up just to make it that it's not too long. Basically just give it a bit of extra coverage under the tab, which gets bent over eventually when you assemble the ring. And then I'll just start winding, and make sure you've got the tail piece sticking out so that you can join that with a tab of the following coil, which has to get soldered onto each other. Now get to the part where the tape has to go around the tab. I just give it a bit of an insert or a shortcut into a section of the tape so that it can fit nicely around the tab. Unfortunately, this is also a bit of a time-consuming job. I've just got the video running a little bit faster. I wouldn't mind being able to do it at that speed. There we go. And once again, make sure you mark it in the right direction. Once you've finished winding them, that's what you start off with on the left hand side, and that's what it looks like on the right hand side with the winding done. The next part is to prepare the Magneto ring, the core. Make sure you've got a good core to work with. Basically sandblast and prime it to start with. And then you must make sure that the core is not buckled or bent in any way. I lay mine face down on a flat surface. I've got a old piece of marble kitchen top, which I use for that. Check with a feeler gauge that there's no gaps underneath or high points, etc. If you do find any high points, you need to have it machined down so that the surfaces, all of the lobes are exactly the same height. Yeah, I've sandblasted this one myself in my little home kit and just primed it. It's not necessary to give it any more painting because it runs in the oil, so it should be fine just keeping it like that. In most cases, this Magneto contact post is reusable. It's a 1 inch by 1 inch by 1 inch triangle. It's riveted to the ring, and this button is basically screwed in. Make sure that it's in good condition and not loose, etc. It's made from a bakelite type of material, which is non-conductive. You can remake them fairly easy as long as it's something that's oil resistant and insulating or non-conductive. You will notice that the first coil will be this one that I mount, and the end where the tail comes out is a little different to the others, where the tails would come out at the bottom end like that, so that they can join up with it with the next one, and that you can see a little bit better in one of the later slides. These are the gaskets that are recovered from the cleaning process initially. If they aren't reusable, you can make new gaskets from flexoid gasket material. It doesn't matter as long as it's insulated from the keeping the coil basically insulated from the Magneto coil base itself. Here you can see everything is fitted. Once again, the right and the left hand, left, right, left, and the tails are brought to that point and trimmed and folded so that they can be soldered. And when I solder them, I would put a piece of gasket material underneath it so that you don't get your solder shorting onto your Magneto ring again. You can also check each one once they're like that with a multimeter, just to make sure that you haven't got a short circuit between the Magneto ring earth and the ribbon itself. So the windings are basically then soldered using ordinary resin, or some people call it resin core or some rosin core solder. If it's necessary, you can use a bit of flux, but don't use acid core. And as I said, put a piece of gasket material underneath when you solder so that you don't get the solder basically soldering onto the Magneto ring. There you can see the soldering has been done and the edges are nice and trimmed. And in some cases where the ribbon is too short, here you'll see there's a joint, so you can fold them and join them if it's necessary. The top one is soldered onto the output button, and the last one is soldered onto the earth point at that point over there. Button, the ribbon going from the top is soldered onto there, and then you need to check whether the coil is now working and you've got no short circuits again. So what I would do there is to apply a 12-volt power supply, and then use a hacksaw blade, and you'll find the hacksaw blade gets attracted magnetically to each of the lobes as you move from the one to the next. If it's not attracted, then there's obviously something wrong with the coil. You can see this in the video clip. Apply the power and just bring in your hacksaw blade, gets attracted to each one. Check, make sure that they're all there. Right, then the next point is to check that your orientation is correct still, just to make sure that you've got your alternating left and right hand windings, or clockwise and anti-clockwise. For this, I would use a compass. Also apply a power supply, and you can see as you move the compass, it will change from north to south as you go around, and that will tell you that the orientation is correct. The next step is to insulate the whole ring with, some people would use varnish and dip it, the whole thing into a varnish bath. What I've been using is an epoxy resin. Don't use a polyester resin because that's not oil and heat resistant. So use an epoxy resin. And basically, create a dam around each of the coils to contain the epoxy because it's quite runny. I use masking tape for that. You'll see in the next slide. Paint the epoxy onto the coils, ensuring good cover. And I've given it about 2 to 3 coats, which is sufficient. There you can see the dam I'm referring to, just to create less of a mess and don't waste too much of the epoxy. It's quite expensive as well. I'll get to the epoxy now. Basically, so you would just paint over, you don't have to paint the lobes themselves because you're going to clean that up in any case. So you would just paint the ring and all the solid areas, etc., to try and isolate, insulate that as best you can. This is the epoxy resin that I used. It's a ProStruct 632. It's a 2-pack kit. Cost me roughly just over 400 Rand delivered. It's something like 360 plus some courier charges. It's available from Stonecore Africa. If anybody needs the details, I can provide that for you later on. Just contact me and I can give you the details if somebody needs that. There you can see the epoxy that's been applied. What I would then do is just take a carpet knife and cut the loose pieces off, which from the masking tape, once you remove the masking tape, and any edges that are sticking out too far. And then also I would use a Dremel with a small flapper disc or a sanding disc on and clean up the surface of the lobes. If you use a baby grinder with a flapper disc, you need to be very careful because it runs at such a high speed. Make sure that you don't damage the coating that you've just applied. That's why I prefer using a Dremel, which is a little bit easier to control. Then the next one is the Magneto mounted onto the engine block, ready for installation of the transmission. And it's obviously critical to maintain the gap between these lobes and the magnet, the shoe of the magnet, which holds the magnets on the transmission. That must be between 25 and 40 thou. And that's the reason why your core must be 100% level or flat when you start off with. And just to get back to that slide, once you mount this on, you need to make sure that the ring is 100% perpendicular to the crank flange. You can make a device to test that with, fairly simple, or you can purchase something, but they're quite expensive, but you can make a homemade device to turn with a measuring or almost like a dipstick to make sure that they're all the same height. That just makes the adjustment so much easier later on, that it doesn't sit skew. This is the final slide where you can see that's the gap between that little shoe there and the Magneto post, at least the Magneto lobe, which must be between 25 and 40. And you would measure that in a specific position and turn the transmission maybe a quarter turn and check again and another quarter turn, and so that it's in all orientations that you've got that gap and it mustn't touch anywhere. And that's one of the reasons why you need to make sure that it's level, straight and not buckled or damaged. The whole process of doing a Magneto like this is not difficult. It's just a very long time consuming process. I think it took me something like 18, 19, 20 hours to do one. But it's not rocket science, fairly easy to do. And that's basically my bit. If you have any questions, don't hesitate to ask.